You are welcome to this class today. My name is Dr. Kingsley. In my class today, I will be taking you on nomenclature of cycloalkynes. We have done the nomenclature of aliphatic alkynes. Please do see the video, okay? Always subscribe to my video, like and share the videos. Today's class is nomenclature of cycloalkynes. There are some rules that we apply in naming cycloalkynes. Number one, cycloalkynes are named as cycloalkynes. They are named as cycloalkynes, meaning that in their nomenclature, there is what? A prefix before the alkyne. The alkyne is determined by the number of carbon atom. For example, we can have cyclobutane. So cyclobutane simply means that what? That the butane is not in a straight chain or branch chain. Okay, it is in what? Cyclic chain. Cyclobutane can be written as this. Okay, this is the triple bond. Okay, so because there are 1, 2, 3, 4 carbon atom, that's why we call it cyclobutane. The least number of carbon atom that a cyclic compound can have is 3, because it takes minimum of 3 carbon atoms to form a cyclo compound. So we can have a compound this way, which is what? Cyclo, okay, propyne. Okay, and this is a cyclohexane. This is cyclohexane. So 1, 2, 3, 4, 5, 6, 7. Okay, when you count the sides, carbon 1, 2, 3, 4, 5, 6, 7. Okay, if there is a triple bond here, this is a cycloheptane. So the nomenclature of what? Cycloalkynes, we put cyclo, okay, before the what? The parent compound. All right, that is a rule 1. Then rule 2 to name this compound is, if there is a substituent, then the numbering of the carbon atoms becomes important. If we have this, okay, and there is a substituent here, okay, you need to number before you name. Now, when we are numbering cycloalkynes, we number in such a way that what? That the vinylic carbon, okay, the carbon atoms bearing the what? The triple bond take number 1 and 2 position. So if this is the triple bond here, either this one is number 1, or here is 2, or here is 1, here is 2. As you see here can either be 1 and here is what? Is 2. That is the first rule in numbering the cycloalkynes. You number in such a way that the triple bond takes 1 and 2 position. But the one that you go through to be 1 or 2 also depend on the substituent. Okay, you give the substituent the least number possible while considering the what? The triple bond. What we mean by this is, if we take this carbon to be 1, here become 2, then the substituent become at number 3. But if we take here to be 1, here become 2, 3, 4, 5, and 6. The substituent become number 6. So it is very important for us to do what? To place our numbering here. So that here become 1, 2, 3, 4, 5, 6. This will give what? The substituent the least number possible, while also considering the what? The triple bond. Now, if we want to name this compound, we name the substituent first. So the substituent is at number 3rd position. So it becomes 3-methyl. Okay, we can now name the what? The parent compound, which is what? Cyclohexane. So without the substituent, this is cyclohexane. But with the substituent and number 3, 3-methyl, then we name the parent compound, which is cyclohexane. Now, number 3, if we have 2 or more substituents, that is the third rule. When you have 2 or more substituents, you will name them alphabetically. You name alphabetically. Okay? Let's say we have, okay, a cyclobutane, and there is what? A substituent here, which is Br, and there is another substituent here, which is a CH3. Okay? CH3 is a methyl group. So we have Br and CH3. Now, this carbon atom, we take either 1 or 2. When we do what? When we take this one to be 1, here becomes 2, and here becomes 3. Then here becomes 4. But when here is 1, here becomes 2, here becomes 3. So in any way we number from, you can see that substituent will be at number 3. Now, if substituent is number 3, or in number 3 position from either side, then we consider what? Alphabetization. Which of this alphabet comes first? Is it B for bromo or M for methyl? You can see that B comes first. So we number to give what? B, which is bromo. Okay, the least number possible, while considering the what? The triple bond. So this is number 1, and this is number 2, this is number 3, and this is number 4. So the name of the compound is 3-bromo 4-methyl. Okay, we can now name the parent compound, which is a cyclobutane. So that is the name of the compound. So we have 3-bromo 4-methyl cyclobutane. So that is rule 3. Now we are going to rule 4. Rule 4 is telling us that if we have what? If we have, 2 or more triple bond, 3 or more triple bond. Let's say we have a compound of this nature. This is a triple bond here, and there is another triple bond here. So we see that we have what? 2 triple bond. Now, if we want to name this compound, we see number to give the what? The triple bond, the least number possible. So this is 1, 2, 3, 4, 5, and what? 6. So this is what? Cyclohexane 1,4-diene. Triene. Diene. Okay, thank you. So when we have 2 or more of triple bond, we name the alka, which is what? The parent what? Compound, which is cyclohexa, because we have more than what? 2 triple bonds. So we use what? Alka, which is cyclohexa. Then we put the what? The position of a triple bonds. Okay, then followed by what? Followed by the number of what? Triple bond that we have. If it is 2, it becomes diene. If it is 3, it becomes a triene. Then that is number what? Number 4. Then number 5 rule. If we have both double and triple bond, okay, in the cyclic compound, we give preference to the N. So we number in such a way that the N, okay, is preferred, is gotten the lowest number possible. Now, when we have a double bond and a triple bond here, how do we number? Remember, one is double bond or triple bond. The double bond will always take 1, 2, or the triple bond will take 1 and 2. But we are saying that what? we are giving the double bond the preference. Okay, we number to give the double bond the least possible number. Okay, so if here is 1, here become 2, here become 3, here is 4, here is 5, and here is 6. So that is how to number when you have double bond and triple bond. The double bond is what? Giving the least number possible. So the name becomes what? It becomes cyclo, okay, hexa, okay. Then we put the position of the double bond, that is what? 1. Then that of triple bond, which is what? Okay, 1 in, okay, because the in is at number 1 position. Cyclohexa 1 in, then the position of the triple bond is 4 in. That becomes the name. Cyclohexa 1 in, then 4 in. So in is giving preference, okay, to in. I know you might want to ask, why is it that we are giving preference to in before in? Okay, there are so many reasons why. IUPAC, okay, gave what? Gave the in preference over in. The first reason is that what? The in were already first discovered, okay, before the in. So there's already a naming system for what? For in, before the in was now discovered. Then number 2 is that what? The ins, that is alkanes, they what? They react what? Faster than what? Than alkynes. So which of these, in and in, okay, is more reactive? We say that what? In is more reactive than what? Than in. Remember, the ins, they have what? Double bond. While the ins have what? Triple bond. Now the ins have only 1 pi bond, while the ins have what? 2 pi bonds. Now 1 pi bond is more freer than what? Than 2 pi bond, because the ions, okay, the electrons, the pi bond electrons in ions are what? Are drawn closer to the nucleus. So that makes what? Ion to be what? The bond to be shorter than the ins, meaning that the pi bond in what? In ins is more loose, so it can easily be what? Be broken, because if it is loose, that means it is weak. So that is why if you are adding what? If you are adding bromine, okay, to this, and you are adding bromine to what? Triple bond, you see that what? That these ions will require 2 what? Molecules of bromine, while in will require only 1 molecule of what? Of bromine. Now, for the first step of the reaction of ions with a bromine, we measure the what? The speed, okay, and this one we also measure the what? The speed. You see that this one, the speed is faster than this, so this one is more reactive than this, because the pi bond in is weak, okay, loose, and can easily be broken in comparison to what? To the ions. So that is the reason. I believe you have learned something from here. Please, I want you to always help me to share my videos, like them, and subscribe. Don't watch without what? Without subscribing. Okay, this class will be very important for those who are preparing for AP, okay, GCSE, okay, exam, SAT exam, NECO, WAEC, and UTME. So share to as many as your friends who are writing these exams. Thank you very much.